So today we're going to be talking about equilibrium and the Chatelier's principle. So that states that when a system is in equilibrium and experiences a disturbance such as a temperature change, a concentration change, or a pressure change, it will react in a way to reform a new equilibrium. And today we're going to be talking about the effects of pressure on equilibrium. So I have my bottle of Coca-Cola and a glass. Excuse me. And in this bottle, we have CO2 gas in the top and then CO2 aqueous in the solution down here. And in a closed system, they equal each other, so they are in equilibrium. However, once you open, you hear that fizz, you see bubbles start to form. That is the CO2 gas escaping, which causes the system to shift, which causes the equation to shift to the left. So as we're pouring this in here, you can get a better sight of the bubbles rising. And this is the CO2 aqueous coming up, which is also like shifting to the left of the equation to rebalance the equilibrium and make up for the CO2 gas that was lost because of the larger volume. And so I have my bottle open, but once I close it back, it is back into a new closed system. And there will be eventually more bubbles that start to rise in here just to balance out the CO2 gas in the top, and then they eventually reaches equilibrium again. But if I open it again, you don't hear as much of a fizz, but once pouring it back in, you have another disturbance, and then you have equilibrium reached again after closing the lid back. So that is the Chatelier's principle and the effects of pressure on equilibrium.
This is a visual representation of the chemical equation behind it and what is going on. So as volume increases, the pressure decreases. And when we open the bottle, the volume increased, causing that pressure to decrease. So when you look up here, the gas of CO2, the pressure decreased on it, which caused the CO2 aqueous that was in the soda itself to shift the equilibrium towards the reactants to try to increase that CO2. Now, since it was open, this same thing would happen over and over again because we were in an open system after opening the bottle and pouring it into the glass. So that would continue on until there was no more CO2 aqueous left to make CO2, left to balance out CO2 gas. So, but once we closed the bottle, it went back to a closed system, and this eventually remained constant and didn't have to keep going in a process like that.